there might be few MCQs which might be aligning to the previous one, but we'll still go through all of those. All right. So what you all have to do is tell me the tell me the answer which you think is right, and then we'll discuss upon it briefly. All right. Can we start? Can we start?
Yes, ma'am.
All right. Yeah. So first one, flocculated suspensions exhibit which type of flow? This is a very direct question from rheology. What flow does flocculated system exhibit?
C, plastic.
Very good. Yes, so the right answer is C, plastic. What about dilatant? Dilatant is observed by? So dilatant is observed by deflocculated suspensions. Okay, deflocculated suspension. D for deflocculated and D for dilated. All right. Newtonian is like your water and other small molecules. All right. Pseudoplastic is exhibited by hydrocolloids and all. Okay. So that is how this goes like. Moving on to question 2. Yeah, so the answer was plastic. Moving to question 2. Which of the following is not a 1-point viscometer but can be used for the same purpose? The question is which of these is not a 1-point viscometer but it can be used for that as well. Look at it one by one. Is falling sphere a 1-point viscometer? What is a 1-point viscometer? A 1-point viscometer is a viscometer which measures viscosity at one shearing stress. Okay. You can't really change the shearing stress in that. So what is the Oswald viscometer? Oswald viscometer is a 1-point or a multi-point?
1 point.
Very good. This is a 1-point viscometer. What about falling sphere? So falling sphere and rolling ball, both of them again are 1-point viscometer. All right. These are 1 point. Along with that, even Hubelode. Even this viscometer is a 1-point viscometer. So the correct answer here is a cup and bob actually. Let me just mark the correct answer. Okay. So cup and bob is not a 1-point viscometer. Okay. It's a multi-point viscometer. But you can also measure the viscosity at one shear stress as well. Okay. So, and you can measure at different shearing stress as well. Clear, everyone? Hello?
Yes, ma'am.
Yes.
Yes. Which of the following flow is exhibited by a deflocculated suspension? We just discussed. That too with a high concentration of dispersed solid. What is the answer? We just discussed.
Dilatant.
Dilated. Very good. Okay. Brookfield viscometer is an example of what type of a viscometer? First, tell me, Brookfield viscometer is a 1-point or a multi-point? Is it a 1-point or a multi-point?
Multi-point.
Correct. It's a multi-point. Now tell me, as per its configuration, its structure, what kind of viscometer is it? क्या दिखता है ये वाला?
Rotating spindle.
Spindle. Very good. It's a rotating spindle kind of a thing. So it looks something like this. Okay. ऐसे करके होता है. 4 बार. All right. So this is like a spindle here. ऐसे भी होता है. Sometimes it's just like this also. All right. So that is how a Brookfield viscometer looks like. Which test, and coming to the other ones, cone and plate wala, you all know, it looks like cone and this is the plate. So plate becomes the stator and cone is the
rotor.
okay. Even cone and plate is a multi-point viscometer. ठीक है. रोटेशन स्फीयर वाला नहीं होता है. We have something called as a falling sphere. And as we discussed, falling sphere is a 1-point viscometer. All right. जिसमें एक ट्यूब में you put the sphere and then ये ट्यूब को सीधा करते हो एंड ये स्फीयर को ये पॉइंट से ये पॉइंट, ओके, ये पॉइंट से ये पॉइंट आने में कितना टाइम लगता है, दैट इज नोटेड डाउन. ओके. सो दैट इज अ फॉलिंग स्फीयर काइंड ऑफ. ठीक है. अंडरस्टूड एवरीवन?
Yes, ma'am.
Okay. Which test is used to determine emulsion stability? Emulsion की stability को कौन सा टेस्ट से you will determine? Okay, so first let us understand that emulsion ka stability are of two types. You have chemical stability. You have you also have physical stability. ठीक है. You also have microbiological stability to test के there is no, मतलब जो sterile वाले होते हैं emulsions है तो उसका microbiome study भी करोगे कि कितना sterile है and all of that. Okay, so this is for sterile emulsions. ठीक है. So now you have physical and chemical instabilities. Okay, हम ये instability issues की बात कर रहे हैं. Instabilities emulsion में तीन टाइप की होती है, मेजरली दो है, chemical and physical. Chemical stability is because of drug degradation. Okay. Physical stability is because of say coalescence हो जाता है या cracking हो जाता है. Okay. या phase inversion हो जाता है. Okay. So now tell me, ये सारे को कौन सा टेस्ट amongst these four तुम्हें हेल्प करेगा? Can you measure these things by density test? हाँ? No. No, exactly. Because density will just tell you कि भाई oil phase का density कितना है, water phase का कितना है, overall emulsion का. So वो stability का idea नहीं देगा. What about solubility test? Solubility test will tell you what kind of emulsion is it. Is it oil in water or water in oil? Okay, that is what solubility test is going to tell you. इसको दूसरा dilution test भी बोलते हैं. Dilution. Viscosity test तुम्हें stability का बोलेगा?
No.
No, viscosity is just going to have a very direct thing कि भाई how much viscous is it. ठीक है. So the answer here is centrifugation. Centrifugation test से you will get to know कि तुम्हारा break तो नहीं हो रहा है emulsion. Okay. Ideally, when you're centrifuging your sample at a high speed, ये centrifuge tube में, when you're keeping your emulsion, जिसमें oil and water phase properly mixed होना चाहिए. ऐसे नहीं. So अगर based on the density, if it separates, कि oil is less dense तो oil ऊपर आ गया and नीचे पानी रह गया. Okay. अगर वो separate हो रहा है eventually, मतलब it is less stable. But even after centrifugation, अगर वो homogeneous dispersion जैसे ही रह रहा है, that means it's more stable. Understood?
Yes, sir.
Okay. Which of the following stabilizes a suspension by increasing the viscosity? पहले तो ये बोलो, suspension में जो हम viscosity increase करने वाली excipient डालते हैं, उसको क्या बोलते हैं? What is the excipient called?
shear
Which,
thinning.
sorry?
shear thinning होता है ना वो?
No, I'm telling you, suspension में viscosity बढ़ाने के लिए the excipient which we put, okay? What is that
Polymer.
excipient called? No.
Viscosity.
Polymer is the example of that excipient. Okay, yes, polymer will help you increase the viscosity of suspension. But what is that category of excipient called?
Viscosity modifier.
Correct. Viscosity modifiers. Viscosity modifiers or viscosity enhancers. And they can also be your suspending agents. Okay? ये सब तुम्हारा विस्कोसिटी बढ़ाने का काम करता है. नाउ इसका एग्जाम्पल इज अ पॉलीमर. ओके,
Carbopol.
पॉलीमर वीगम भी हो सकता है. ओके, वैसे. सो अमंग्स दिस व्हाट do you feel is the answer? Which of these helps?
Carbopol.
Everybody? Pragnya, what do you think? So
Carbo.
obviously the correct answer here is carbopol. Even carbopol is a type of polymer. इथेनॉल से विस्कोसिटी नहीं बढ़ेगा. इनफैक्ट दैट विल मे बी दैट कैन डिसॉल्व योर एपीआई बिकॉज सस्पेंशंस आर मेड फॉर दोज एपीआई जो वाटर में इंसोल्यूबल होते हैं. करेक्ट? करेक्ट?
Yes, ma'am.
हाँ, बट इथेनॉल यूज किया तो शायद तुम्हारा एपीआई डिसॉल्व हो जाएगा. सोडियम क्लोराइड विल एक्ट एज अ बफर or maybe tonicity modifier if your suspension is used for parenteral. Parenterals mein you need tonicity modifier, correct?
Yes.
Okay. Acetone might also lead to dissolution of your API since ethanol and acetone both are organic solvents. ठीक है? So this can be the issue. So the correct answer is carbopol. Everybody clear with this?
Yes,
Yes, ma'am.
ma'am.
Next. Which type of propellant is preferred for ozone-friendly pharmaceutical aerosol? Abhi, ozone you all know, right? Ozone is a layer in the atmosphere, जो UV से usually spoil होता है. UV से भी spoil होता है. It actually helps Earth be protected from the UV light of the sun. Okay, ozone layer is, if I'm not wrong, it's O3, and it helps you protect it helps the earth protected as a shield against the UV light of the sun. Now there are greenhouse gases. Okay, there are greenhouse gases which leads to ozone depletion. Okay, greenhouse gases ozone को कम करता है, in one way बर्बाद कर देता है उसको. Okay, ozone depletion. So now the question is which type of propellant is preferred for ozone friendly pharmaceutical aerosol? मतलब ऐसा जो ओजोन को खराब नहीं करेगा, ozone friendly. So what do you think? CO2, can that be the right one? Is it a ozone friendly? Hello. No, CO2 is one of the major culprits, even nitrogen. These are greenhouse gases and these lead to ozone depletion. Even chlorofluorocarbon is a big no-no, big no-no. Okay, even that leads to ozone depletion. Easily, it's not even used as a propellant in pharma. It's not also used in any other industry also. CFC is banned. Okay, because of its increased harm to the ozone layer. So the correct answer is hydrofluoroalkane. Okay, it can be hydrofluoromethane or hydrofluoroethane or what. Clear, everyone?
Yes, ma'am.
So I'll always recommend you break down the question and answer. Ozone क्या होता है? And I think this you all should know कि ozone भाई किससे खराब होता है? Greenhouse gases or CFC. CFC has been a major culprit since ages. Okay, so this you should know. Can we move on to the next question?
Yes, ma'am.
Yeah. Yeah. What is the answer for this? The droplet size of microemulsion is
10 to 100 nanometer.
very good. The answer is 10 to 100 nanometer. It's a very direct answer. This you all should know. ठीक है? The ideal pH range for most of the liquid formulation is okay. अभी liquid formulations इधर बोला है. ये question बहुत broad है. सारा liquid formulation है. Now you should know liquid formulation तुम्हारा orally भी दिया जा सकता है. It can be given ophthalmically also. ऑटिक भी दिया जा सकता है, अदर रूट से भी दिया नेजल भी दिया जा सकता है, टॉपिकल भी दिया जा सकता है, एंड अदर मिसलिनियस रूट लाइक रेक्टल वजाइनल वैसे भी दिया जा सकता है. करेक्ट? सबको ये वाला टॉपिक तो याद होगा ना, लिक्विड मोनोफेजिक. सो इट इज आस्किंग अबाउट इन जनरल पीएच रेंज फॉर मोस्ट लिक्विड फॉर्मुलेशन कौन से रेंज में पड़ता है मोस्टली, एंड पैरेंटरली भी दिया जा सकता
B1.
है. करेक्ट. सो अराउंड 4 to 8 का पीएच रेंज में तुम्हारा जनरली लिक्विड फॉर्मुलेशन होता है. नाउ दिस आल्सो यू ऑल शुड नो कि कौन से वाले का कितना होता है. ओके कि कौन से वाले का कितना मतलब पैरेंटरल में कितना होता है, ऑफ्थैल्मिक में कितना होता है, एंड ऑल दीज थिंग्स आर गवर्न्ड बाय व्हाट इज द फ्लूइड इन दैट टिश्यू. ब्लड में प्लाज्मा है. ओके तो ब्लड मतलब ब्लड का पीएच कितना है, आईज में यू हैव टीयर फ्लूइड तो उसका पीएच कितना है. ओके सो ऑल इट विल डिपेंड ऑन आप कहाँ एडमिनिस्टर कर रहे हो. सो अकॉर्डिंगली आपका पीएच टारगेट विल डिफर. यस. नेक्स्ट क्वेश्चन. The process of breaking an emulsion into a separate phases is called what?
Coalescence.
What? I just have Devesh answering. What about the others? Pragnya, Shilpa, Nupur, Isha. Pragnya, what do you think the answer is?
A.
Yeah, very good. Both of you. So the answer is A. Obviously, emulsion breaks down. First, emulsion में क्या होने लगेगा? पहले तो जो ये वन होमोजेनस फेज है, पहले तो वो थोड़ा थोड़ा क्रीमिंग होने लगेगा. ओके ऑयल फेज ऊपर आ जाएगा, वाटर फेज नीचे रहेगा. क्रीमिंग. सो क्रीमिंग इज रिवर्सिबल. ठीक है, यहां से तुम वापस इधर जा सकते हो. बट ये अगर और बढ़ गया देन इट विल लीड टू क्रैकिंग ऑफ द इमल्शन. ये ऑयल कंप्लीटली ऊपर, कंप्लीटली ऑयल इधर, एंड वाटर कंप्लीटली नीचे. दिस इज क्रैकिंग ऑफ द इमल्शन एंड दिस इज इरिवर्सिबल. आप वापस उल्टा नहीं जा सकते. ओके सो क्रैकिंग हैपेंस बिकॉज ऑफ कोएलिसेंस. कोएलिसेंस का मतलब क्या है? योर ऑयल ग्लोब्यूल्स कमिंग टुगेदर. पहले अलग अलग थे, बाद में साथ में आ गए, दो का साथ में आ गए, बाद में पूरा साथ में आ गए, एंड देन इवेंचुअली पूरा एक फेज बन गया. ठीक है, सो दैट इज व्हाट इज मेंट बाय कोएलिसेंस. एंड कोएलिसेंस से you can't go back. It will lead to cracking of the emulsion. What about flocculation? What is flocculation? Flocculation usually happens in suspension, also emulsion. Okay, so इसमें your particles या internal phase जो भी disperse phase है. हाँ, and coalescence can happen in case of water in oil emulsion also. Okay, it depends on the internal phase. So flocculation में what happens is that your dispersed phase or your internal phase will start coming together. there'll be some light interaction between them. Okay, light bonds है, but इसको तुम वापस, this is again reversible. Okay, flocculation is also reversible. उसको shake किया तो again the particles will separate. ठीक है, wetting तो पता है, wetting is to make the hydrophobic drugs or material in contact with water, उसको आने के लिए you do. ठीक है, which of the following is an example of a thickening agent used in suspension? सबको ये previous question समझा?
Yes, ma'am.
Okay.
Yes.
Which of the following is an example of a thickening agent used in suspension?
Methyl cellulose.
Very good. This is a very direct answer, methyl cellulose. Because again, understand, acetone is organic solvent. It can never be used as a thickening agent. कुछ भी चीजों में एसीटोन तुम डालोगे वो पतला ही होगा. For example, your nail pens also, it won't thicken. Glycerine also not used as thickening, it's used as a humectant. Glycerine has the property to absorb water. Absorb or adsorb, जो बोलना है वो बोल लो. Okay, it absorbs water. It's hygroscopic. ठीक है, glycerine. It's used as a humectant to maintain the water level in the formulation. ये dry out ना हो जाए. Propylene glycol, which is PG, is also a organic in nature. It's not an organic solvent, but it's not as used as much as a thickener as methyl cellulose is. हाँ, प्रोपलिन ग्लाइकॉल डालने से विस्कोसिटी बढ़ेगा, विस्कोसिटी एनहांस होगा. ओके, एंड इट्स ऑल्सो यूज एज अ को सॉल्वेंट, प्रोपलिन ग्लाइकॉल, but it won't thicken up your system. Methyl cellulose is used a lot to thicken up the entire system. All right, in comparison to propylene. Clear, everyone?
Yes, ma'am.
Yes, ma'am.
Yeah. In aerosols, liquefied gas propellants function by how? So, yeah, how does the liquefied gas propellants work? Is that gas होता है, उसको तुम हाई प्रेशर लगाते हो, एक्सट्रीम हाई प्रेशर लगाते हो, and you fill it up in a can after high pressure. So these come very close together and they are eventually liquefied. Okay, they are eventually liquefied. So how do they function? So they function by vaporizing to create pressure. So इसमें क्या होगा? I'll just tell you. इसमें क्या होगा? Okay, ये pressure से fill किया. Now when you actuate it, इधर वो button actuator जो होता है aerosol का, जब वो दबाओगे तब ये expand हो जाएगा. ओके, जो ये प्रेशर से अंदर भरा हुआ है वो एक्सपैंड हो जाएगा वापस एज अ गैस फॉर्म एंड इट विल स्प्रेड एंड हेल्प इन द डिस्ट्रीब्यूशन. ओके, दिस विल स्प्रेड. सो दे work by vaporizing to create pressure. Which which type of emulsion is commonly used for topical applications? Very direct. Very direct question.
Second.
ए की बी? मुझे एक बंदे ने ए बोला, दूसरे ने बी बोला.
B.
B1.
No, it's water in oil is mainly used as topical agents. Okay. What is the role of surfactants in emulsions? ये तो नींद में भी आ जाना चाहिए सबको. Emulsions में surfactant का क्या काम है? Surfactants में क्या होता है? You have,
Lower, sir.
हाँ, you have say emulsions में oil and water type का है. Okay, so oil and water एक दूसरे के साथ stable रहेगा? Stable नहीं रहेगा. Stable क्यों नहीं रहेगा? Because of hello, are you all there?
Yes, ma'am.
हाँ, सो ये स्टेबल क्यों नहीं रहेगा ऑयल एंड वाटर?
एग्रीगेशन हो जाएगा।
बिकॉज ऑफ सरफेस टेंशन, उन दोनों के एग्रीगेशन नहीं, सेपरेट हो जाएगा दोनों बिकॉज ऑफ द डिफरेंस इन सरफेस टेंशन बिटवीन देम। ओके, सरफेस टेंशन के वजह से हाई सरफेस टेंशन, so you want something which will help them lower the surface tension, so you use surfactants. All right, so here the correct answer is surfactants are used to lower the surface tension. Increase the viscosity के लिए you will use viscosity enhancers. Okay, preservatives में तुम कौन से यूज करोगे? preservatives you will use something like
Paraben.
parabens are not used that much. You don't really use parabens, but you will use others, antimicrobials and all of that. Okay.
Benzyl chlorine.
Yeah, benzalkonium, benzyl, and all of that. Stabilizing the suspensions? No, it doesn't stabilize this. Yeah, it in one way it stabilizes, but not suspensions. Okay, it stabilizes emulsions. Role of surfactant in emulsions पूछा है. Okay, so it's not for stabilizing suspension, it stabilizes emulsions. But suspension के केस में surfactants का अलग रोल होता है. Surfactants for suspensions, okay, suspension के केस में surfactant is used as wetting agent. Okay, it's used for wetting agent or viscosity enhance. ठीक है? Clear everyone? Any doubts here?
No, ma'am.
Okay. In an aerosol, okay, in an aerosol suspension, the dispersed phase is typically composed of what? अभी imagine what an aerosol suspension. Aerosol मतलब पूरा क्या होगा? एरोजोल में क्या होता है?
Propellant में liquid droplet suspended होता
So it can it
Concentrate
is some,
and
yeah, it is some fluid. Okay, that fluid can either be liquid or gas. Correct? Okay, in a propellant. Now aerosol suspension पूछा है, तो suspension मतलब क्या होगा? अंदर particles होगा. Correct? So what is the answer?
Yes.
What is the dispersed phase in a aerosol suspension?
Liquid droplet.
solid particles.
Solid particles is the answer. Aerosol suspension solid particles रहेंगे, and the dispersion media. Okay, understand one thing. This is the dispersed phase, and these are the dispersion media. This is the dispersed phase, all these, और ये जो surrounding में है, that is the dispersion medium. Okay, so the answer is solid particle. Now next, which type of aerosol formulation is preferred for drugs? Okay, you are again making an aerosol formulation. ध्यान में रखो. So there is some fluid inside it. Okay, which are used for poorly soluble, that are poorly water soluble. Okay, कौन सा aerosol formulation बनाओगे for the drugs which are poorly water soluble but requires delivery to the lungs. Lungs में उसको डालना है. Okay, so definitely aerosol है तो वो lungs तक पहुंचेगा. It can be used. But the drug is poorly water soluble. तो कौन सा टाइप का तुम aerosol बनाओगे?
Gaseous.
No, even that is a solid aerosol. Okay, even that is a solid aerosol system. Clear? Because तुम्हारा ये solubilize नहीं हो रहा है, it will remain suspended only. ठीक है? What is the primary reason for the instability of an emulsion? Huh? What is the primary reason for the instability of an emulsion? Evaporation of volatile phase, fusion or coalescence, polymerization or crystal formation?
D.
Last one.
The correct answer is B.
But
Primary
मैम
reason is
कोएलेसेंस आपने बोला था ना कि एकदम लास्ट में अगर होता है वो इरिवर्सिबल होता है, पहले कि
but
ये होता
crystal
है क्रीमी.
formation. See, crystal formation is something which happens with a solid phase. This can be a problem in suspensions. Okay, when you have solid particles suspended, वहां पे crystallization होगा. And इसका phenomena को हम Oswald ripening बोलते हैं, correct? Oswald ripening है ये. ठीक है? So here the main reason, yeah, the primary reason or the most common reason for instability in an emulsion. Where's the point? Yeah, emulsion के case में it is fusion or coalescence. Okay, that is the thing. And not even evaporation of volatile phase. तुम वैसा phase use करोगे ही नहीं. Is it clear to everyone?
Yes.
All right. Okay. Yes. Next. Which of the following is typically used to characterize the size distribution of droplets in aerosol suspension? So ये droplets है. Droplets माने के liquid droplets. Can you determine size by using HPLC? HPLC से साइज पता चलता है? नो. HPLC से तुम्हें API, तुम्हारा ड्रग कितना क्वांटिटी में है, यू कैन क्वांटिफाई योर API. ओके, क्वांटिफिकेशन के लिए होता है HPLC. स्कैनिंग इलेक्ट्रॉन माइक्रोस्कोप सेम पार्टिकल साइज बोलता है, बट एरोजोल के उसमें काम नहीं आएगा. And SEM is also not the accurate way to measure a particle size. It will tell you about the morphology. कि कैसा दिखता है पार्टिकल, राउंड है, कैसा है, राउंड है, क्रिस्टल है, नीडल है, क्या है. ओके, इवन रिफ्रैक्टिव इंडेक्स वोंट टेल यू अबाउट द पार्टिकल साइज डिस्ट्रीब्यूशन. ओके, सो द करेक्ट आंसर इज डायनामिक लाइट स्कैटरिंग. इसका इंडस्ट्री में, मार्केट में जो मशीन है, वो मशीन का नाम इज जीटा साइजर. Zeta sizer. Okay, it works on the principle of DLS and the manufacturer is Malvern. Okay, clear everyone about this?
Yes, ma'am.
Okay, can we move on?
Yes, ma'am.
What is a potential disadvantage of aerosol suspension in pulmonary drug delivery system? So again, coming in your aerosol drug delivery. Okay, aerosol drug delivery, you have your fluid and you have your suspension है, मतलब क्या रहेगा, कौन से particles रहेंगे?
Solid.
Solid particles. So your solid particles are the dispersed.
Phase.
Very good. Dispersed phase, and ye will be your dispersion medium. Now tell, what can be the potential disadvantage if you're using it?
Particle aggregation.
Very good. Particle aggregation can be a major disadvantage because यहाँ पे तुम्हारा drug liquefied नहीं है. It's in a solid form. So what if it aggregates, right? So that is a potential disadvantage. Next. In the preparation of a suspension, the particle size of the dispersed phase is typically between what range? It's a very direct question. Suspensions में particle size, मतलब जो suspended particle है, उसका range क्या होना चाहिए? It's a direct thing. You all should know it should be around 1 to 10 micrometers. ठीक है? In case of suspensions. Okay. HLB value of an emulsifier is used for what? First tell me what is an HLB scale? HLB scale क्या होता है? जो हाइड्रोफिलिक लिपोफिलिक स्केल होता है, बैलेंस स्केल होता है, वो किसके लिए होता है?
It is based on the HLB value, which type of agent we can use for our emulsion.
हाँ, so it tells you कि वो surfactant का नेचर क्या है. Either it is whether it is hydrophilic or whether it is hydrophobic. Correct?
Yes.
Correct? So it tells you that कि हाइड्रोफिलिक है कि हाइड्रोफोबिक है. अभी हाइड्रोफिलिक सर्फैक्टेंट्स कैसा इमल्शन बनाएगा? सबको ये याद है रूल ऑफ बैनक्रॉफ्ट. रूल ऑफ बैनक्रॉफ्ट. What is rule of Bancroft? What is rule of Bancroft? Rule of tell कौन बोल रहा है?
अगर इमल्सिफायर वाटर में सॉल्युबल है तो वो ऑयल इन वाटर इमल्शन बनाएगा.
Very good. Very good. Okay. And so what Pragnya said is HLB rule of Bancroft is कि depending on the nature of the surfactant, whether it is hydrophilic or hydrophobic, okay, that will decide what the external phase is or what the continuous phase is. So if it is a hydrophilic, then that means it's soluble in water. So that means the continuous phase will be water and under will be oil. So it will form an oil in water type of an emulsion and vice versa. Okay, if it's hydrophobic, it is soluble in oil. So it will form a water in. Okay, so that is rule of Bancroft. Abhi, how will you know that it is hydrophilic or hydrophobic? How will you know if your surfactant is hydrophilic or hydrophobic? You will know that by the HLB scale.
Value.
Correct? The HLB value. So now answer this question.
A.
Okay. So your HLB value of an emulsifier will use to determine के कौन सा type का emulsion बनेगा. So the answer is A. It won't tell you measure the solubility of the emulsifier. वो तो HLB scale बोलता है. Okay. But what is it used for? To determine the type of emulsifier. Okay. Emulsion which is it going to form. Rate of drug release भी नहीं बोलेगा and particle size भी नहीं. Okay. And it is not used to measure the solubility. Based on the solubility उसको ranking दी गई है HLB से. ठीक है? Which type of formulation is used for drug that are poorly water soluble and need to be administered to the lungs? ये again repeated question. एक मिनट भी नहीं लगना चाहिए इसका आंसर देने में. प्रज्ञा, you're mute.
B.
Correct. Aerosol suspension. ये repeat question था. Okay. In which type of liquid formulation alcohol is commonly used as solvent?
Elixir.
Very good. Elixir. Okay. Elixir को क्या बोलते हैं? कौन सा टाइप का solution बोलते हैं? Dash.
Hydroalcoholic.
Very good. It's a hydroalcoholic. Okay. Emulsion में it is not alcohol. It can either be water or oil phase. ठीक है. Suspension में भी it can be water or oil phase. Water मतलब it can also be buffer. Syrup में what is the continuous phase? It is sugar based solution. Correct? That is what syrup is. Sugar based solution. Now the term tincture refers to a liquid dosage form in which the active ingredient is dissolved in what? एक एग्जाम्पल बोलो, टिंचर का एक एग्जाम्पल बोलो, क्या है?
आयोडीन।
आयोडीन पेंट है, बट आयोडीन टिंचर्स भी होते हैं, और एनी यू हैव डिफरेंट हर्बल टिंचर्स आल्सो. नाउ यू टेल मी, इसमें जो मेन एक्टिव इंग्रेडिएंट होता है उसको किस में डिसॉल्व करना होता है?
वाटर अलोन।
ओके,
अल्कोहल पे श्योर नहीं है, वाटर तो
इट
होता
इज
है।
नो, इट कैन बी अ alcohol based.
Alcohol.
Yeah, tinctures are alcohol based also. Tinctures are basically used as to extract out things from herbal sources. Okay, herbal sources का या फिर इवन अदर कंपोनेंट्स का उसका एक्सट्रैक्ट जैसा बनाते हैं, कॉन्सेंट्रेट जैसा बनाते हैं. दे आर टिंक्चर्स बेसिकली. सो इन दैट जब भी एक्सट्रैक्शन का आ जाता है तो अल्कोहल बाय डिफॉल्ट माइंड में स्ट्राइक होना चाहिए. ओके, सो इट इज अल्कोहल और अ मिक्सचर ऑफ अल्कोहल वर्ड. The addition of which of the following help to an oral liquid formulation can help prevent precipitation of the active ingredient? कौन सा excipient will help prevent precipitation? Okay, precipitation कब
बफर।
होता है? हाँ, what?
Antioxidant.
No, antioxidant. The answer is buffer. So buffer, precipitation कब होता है? Precipitation तब होता है when there is some pH change. Okay, जब pH change हो जाता है, okay, there is some problem with the solvent. Mainly pH change के वजह से precipitation होता है. Okay, या फिर if crystallization होने लगता है because over the time stability में pH change होता है. ठीक है, तो बफर काम क्या करता है? बफर का तो काम ही है pH मेंटेन करना. Okay, so that is why this is going to prevent crystallization or precipitation. Sweetener तो it's just going to sweeten up the thing. Flavoring agent भी flavor करने वाला है. Antioxidant का काम is to prevent oxidization. Okay, prevent the oxidation of the drug. अभी oxidation leads to chemical degradation. केमिकल डिग्रेडेशन मतलब तुम्हारा ड्रग का क्वांटिटी अगर पहले 100% होगा, देन ऑक्सीडेशन से डिग्रेड होके मे बी इट विल बिकम 90%, 80%. इट विल लीड टू इंक्रीज इन द इम्प्यूरिटीज. ओके, वो सब होगा. तो वो सब प्रिवेंट करने के लिए एंटीऑक्सीडेंट. बट जो प्रेसिपिटेशन है दैट इज अ फिजिकल इंस्टेबिलिटी. ओके, दिस इज अ फिजिकल इंस्टेबिलिटी, एंड इसलिए यू यूज बफर. इज इट क्लियर फॉर एवरीवन?
Yes, ma'am.
Okay. Which of the following would most likely result in the instability of a pharmaceutical emulsion? Read it. Which of the following would most likely result in instability? Quick, quick, quick. What's
लास्ट
that?
ऑप्शन।
Yes, the last option. The main point of emulsion is that there should be some repulsion between the oil droplets or whatever the droplets are, so that they don't merge together. Okay, अगर दोनों में if there will be some repulsion, then they won't come together. Okay, repulsion hai. But if there is attraction between them, okay, if there is attraction between them, they will eventually come together. Abhi, do we want that? We don't want this. Okay? We don't want this. We want them to stay away. We want them to stay away. So, abhi electrolytes kya kar raha hai? It is reducing the electrostatic repulsion. Electrostatic repulsion reduce hoga to kya hoga? Agglomeration hoga. Agglomeration se coalescence hoga and then break hoga and then that is your instability. So, the instability, which of the following would most likely cause an instability is presence of electrolytes, which reduces the repulsion. Clear, everyone? Moving on. What is the primary purpose of using cyclodextrin in pharmaceutical formulation? So you have cyclodextrin like HP beta CD, okay, hydroxypropyl beta cyclodextrin, HP gamma CD, gamma cyclodextrin, alpha cyclodextrin, okay, hydroxypropyl cyclodextrin. So उसका काम क्या है?
A.
Increase the solubility by complex formation. So cyclodextrin is a cup-like thing, okay, cup-like thing. बाहर पे उसके OH groups है, okay, बाहर साइड उसके OH groups है, and अंदर के बाजू it is hydrophobic, okay, अंदर it is hydrophobic and बाहर it is hydrophilic. So when your drug is, okay, when you have a drug which is not soluble in water या फिर less soluble in water, तो उसको हम cyclodextrin के साथ complex बनाते हैं, okay. So drug तुम्हारा basically क्या है? Hydrophobic है. तो वो ड्रग को तुमने इधर डाल दिया बिकॉज अंदर का साइड तो साइक्लोडेक्स्ट्रिन का हाइड्रोफोबिक है एंड बाहर के साइड OH है, तो वो वाटर के साथ H बॉन्डिंग बनाएगा, करेक्ट, एंड दैट इज हाउ देयर विल बी एन इंक्रीज इन सॉल्युबिलिटी. ठीक है, अंडरस्टूड? अंडरस्टूड एवरीवन?
Yes, ma'am.
Okay. Which of the following methods is commonly used to enhance solubility of a poorly soluble drug in solid dosage form? सॉलिड डोजेज फॉर्म में, ओके, किसी का सॉल्युबिलिटी बढ़ाना है तो क्या करेंगे? पार्टिकल साइज रिडक्शन करोगे, ओके. सो बड़े पार्टिकल्स को when you break down to smaller particles तो उसका surface area बढ़ेगा, right? More surface is exposed, so this will help in increasing the solubility. This is a very common thing, particle size reduction to increase surface area. Now that will help increase the solubility of a poorly soluble drugs for a solid dosage form. Now the last question, Noyes-Whitney equation is used to describe what? Noyes-Whitney equation किसमें पढ़ा है हमने?
Solubility and dissolution.
Correct. It's used to establish a relation between solubility and dissolution. Okay. So that's all from my side for this MCQ session. Have you all understood everything? Have you all
Yes.
understood everything? Okay. All right then. Any doubts?
No, ma'am.
Okay. ठीक है. So, all right then. I had, okay, there are no doubts in the chat box also. So thank you. So that was all from my side. Again, with some MCQs on pharmaceutics. All right. And I think we'll meet again for the next class. Okay, so we can
Yes, ma'am.
meet again tomorrow. All right. Okay,
Ma'am,
then.
you will send the PDF, no, for this?
Yes, yes. The admin will share with you.
Okay, ma'am. Thank you.
Norman, you can talk to Norman. He will share it. Okay. But I hope you all have understood everything.
Yes, ma'am.
So some things you all have to memorize. Okay, जो values है कि इसका particle size क्या होना चाहिए. While teaching liquid dosage form भी मैंने तुम लोगों को बोला था कि भाई क्या बोलते हैं, you have to know the pH ranges कि otic solution का pH range क्या होगा, parenteral का क्या होगा, ophthalmic का क्या होगा. ओके कितना वॉल्यूम अपन एडमिनिस्टर कर सकते हैं. तो those things you all should know. Okay, so those things are direct questions, so don't try to lose marks over there. Applicative questions be, if you all know the concepts, it will be easy for you to answer, right? And if you all have any doubts, you all can reach out to me. All right then. Okay, all right then, bye bye. Hello, yeah, bye.